The We Love Yous Bank extends personal loans to approved customers. A random sample of N personal loans is taken. A 99% confidence interval for the population mean loan mu in thousands of dollars based on this sample is 10.2 to 25.4. What is the mean personal loan for this sample? Well, the mean will be at the middle of the confidence interval. So we just need to do 10.2, add 25.4, and divide that by 2, giving us 17.8, which is $17,800. In part B, we want to calculate the standard deviation for the sample mean. So we know that the standard error is going to be the mean take away the lower boundary, which is 7.6. The standard error is equal to the z-score times the standard deviation. So 7.6 is equal to the z-score for 99, which we can get from our calculator in various ways, including using the z-score for CI. And we'll just change that to 0.99 and solve. And then we can see the value there. So we'd use 2.5788 times sigma. And so our sigma is just going to be the 7.6 divided by that, which is 2.95, and that will be 2950. Ali exclaims excitedly, "Everyone here at We Love Yous is 99% certain that the true population mean is within the interval 10.2 to 25.4. State 2 reasons why Ali is not correct. There are various things that you could say here. Any single confidence interval may or may not contain the true mean. The mean is unknown. Third one is repeated samples. Approximately 99% contain mu, but we can't say anything about the single one, which we've already mentioned. And lastly, we're not told n. If n is less than 30, then the normal model is not valid, invalidating the confidence interval itself. So, moving on with this question. A data analyst discovers that the sample size was actually 2n. In addition to this, the sample mean was actually $2,000 more than originally determined. Recalculate the 99% confidence interval for the population mean on the basis of the updated information. Well, the 2,000 is going to translate up by 2. That's only going to affect the mean. It's not going to affect the standard deviation. We know that just moving up or down doesn't affect the spread of the data. The 2n is going to scale by a factor of 1 over root 2. And just think about how it's calculated. We have x bar over n. Well, it was root n before, and now it's root 2n. So there's 1 over root 2. So the width is going to be 2.5758, that's our Z99 value again, times S over root 2n now. So that is equal to 2.5758 times S over root n multiplied by the 1 over root 2. And this is the value that we had before. So that's 7.6 times 1 over root 2, giving us 5.37. So for the confidence interval now, we have 17.8 was at this end, plus 2 take away 5.37. So 17.8 was the middle, of course, not the end. So that'll be less than mu is less than 17.8 plus 2. This 2, of course, is the 2 that we're translating up by because of the 2000 just here. And that one will be plus 5.37. And so just calculate that, and it gives us 14.43 and 25.17.